Okay, in this lesson, we're going to be talking about the law of sines. So, before we get to what is the law of sines, let's do a little geometry review. Let's take a look at these two triangles here. Okay, we've got two triangles, and we've got some markings on each one. So notice that we've got one pair of congruent angles, we've got a second pair of congruent angles, and then we've got a pair of congruent sides. So going back to geometry, if we were going to try to prove that these two triangles were congruent, then we could use the shortcut angle, angle, side. We've got two pairs of congruent angles and a non-included side. So that side's not included between those two angles. All right, so we could use angle, angle, side. If we go to these two triangles here, so now we've got another pair of angles, we've got a pair of sides, and then if this is a right angle, then this is a right angle. All right angles are congruent. So then we have a second pair of angles, and because that side that's congruent to the corresponding side in this triangle is in between, or is included between these two angles, then we would make that S in between the two A's. So we would have angle, side, angle. Okay, if we go to our third pair of triangles, we've got a pair of angles in the right angles. We've got a pair of sides that are marked with a tick mark. And then we've got a second pair of sides. They share that diagonal there. Okay, so looking at the relationship between our angle and our sides, that angle is not included between the two congruent sides, so we want that A not in between the two S's, okay? And we definitely want to put it at the end. So SSA. Now this was not one of our shortcuts in geometry, but it's good to recognize that that is SSA. This would actually be HLT if we were actually proving these two triangles congruent, the one unique case of SSA that works. But SSA is going to be important to us, as is ASA and AAS, just in recognizing what angles and sides we have given to us and what their relationship is to each other. It's going to be important to us when we look at the law of sines. So, what is the law of sines? The law of sines says in any triangle ABC with capital A, capital B, capital, and that should be with angles, big A, big B, big C, and they have opposite sides, little a, little b, and little c, okay, respectively, just like we talked about when we talked about right triangle trig. Little a is the side opposite angle A. Okay, so the law of sines says this, that the sine of angle A over side A has got to be equal to the ratio of the sine of angle B over side B, has got to be equal to the sine of angle C over side C. Okay, so the ratio of the sine of an angle to its opposite side is the same for each pair in a triangle. Okay, and this works for any triangle. This isn't just for right angles. So now we're starting to apply trigonometry outside of circles and outside of right triangles to any triangle here. All right, so again, with an equation that's a complex equation where we've got multiple parts, we can take just a chunk of it, or these two pieces, or these two pieces on the end, and just set two pieces equal to each other. That's what we're going to want to do here. All right, let's look at some examples. Okay, example number one. Solve triangle ABC if angle A is 48 degrees, measure of angle B is 22 degrees, and side A is 5 degrees. Okay, we're not given a picture, so the first thing we want to do is draw a picture. And we're only given a little bit of information about our triangle, so I'm just going to draw a generic triangle, label it ABC. We're going to assume that all the triangles we draw for this unit are not to scale, just like you would do in geometry class. So that what matters is the actual measures that are given or that we find, and not what it looks like on paper. Okay, so we've got triangle ABC, and I would go ahead and let's see, and fill in what we know. So we know angle A is 48 degrees, angle B is 22 degrees, and side A, opposite angle B, angle A, is 5, let's give it some units, let's call it inches. Okay, the other thing we're going to do before we get started with the law of sines is we're going to make a little table. Okay, so when we solve a triangle, we want to have all three angles solved for and all three sides solved for. So let's put all that information into a table. Okay, so we've got spots for all three angle measures, all three side measures. And again, let's go ahead and fill in what we know. We know angle A is 48 degrees. Angle B is 22 degrees. We don't know C, so we're looking for that. We know side A is 5 inches, and we're looking for side B and side C. So this kind of helps us see what we're looking for. This also helps me, if I'm grading this on a quiz or a test, just to easily find your answers, in addition to looking at your work, which will be below. All right, so starting off with, so we've got our diagram with the given information in it. We've got our table started. I want to look at my diagram and see what's the relationship between the angles and the sides. So similar to the way that we did the angle, side angle, side angle, and all that stuff, I've got two angles that are given to me, and I've got a side. The side is not included between those two angles. This would be the included side. So I'm going to call this one an angle-side problem. Okay, so anytime that we're given two angles and a non-included side, then we can use the law of sines to solve this triangle. All right, so angle-side is our first type of triangle. So we're going to start off with our law of sines, and we're going to look for the pair of information that we're given. So an angle and its opposite side. We're always going to start off with that pair. So I'm going to say the sine of 48 degrees over 5 is equal to, and then I'm going to use the other piece of information that we're given. Okay, so I know that angle B is 22, so I'm going to say the sine of 22 degrees, and then the side opposite big B is little b. Okay, so this kind of forces us to solve for side B first. Now, we could have gone and found angle C first. That would have been just as easy since we know two angles. We know that 180 take away 22 take away 48 would give us the measure of angle C. We could do that. So we've got, let's see, minus 10, that's going to be 60, 70, should be 110. Okay, so measure of angle C is 110. We could go ahead and fill that in. So we've got all our angles covered. Now let's go back to our law of sines here. Okay, we're looking for little b. If we want to solve for little b, then we can do cross products since we've got a proportion. So that would give us b times the sine of 48 degrees equals 5 times the sine of 22 degrees. And again, we're solving for b, so let's divide both sides by sine of 48. Okay, so now we've got b solved for itself. We've got this expression here. We cannot cross out those two signs. We cannot simplify what's inside those signs. We've got to put this big chunk into our calculator. Okay, because we want our side, and we're going to go ahead and round to 3 decimal places. So in your calculator, make sure that you are in degrees mode. So make sure you're going into mode, and make sure that degrees is selected. Okay, since we're dealing with degrees, so go ahead and do 5 sine of 22 over the sine of 48. And that should give us our side, and we're going to round it to 3 decimal places. So 2.520. Okay, so I'll put it there. I'm going to go ahead and put it on my diagram. And most importantly, I'm going to put it in my table. Okay, so now we just have C remaining. So we need to solve for side C. So what we can do next is we can set up another iteration of law of sines. Okay, I'm going to stick with the one that I started with. Alright, well, we could use sine of b over 2.520. Since we rounded this one, it's better to stick with our exact answers that we have. Okay, so then we're doing sine of 110 degrees, since that's angle C, and we're looking for side C. Okay, so again, solve for C. We should get that C equals 5 sine of 110 degrees over sine of 48. Okay, doing our algebra. And then plugging that into our calculator. We should get 6.322. 6.322. Okay, that's our C value. It's in our table. It's on our triangle. And each of our sides are in inches. Make sure we have our units. We've got our degrees, and we're done. Okay, so we solved for that triangle. We found all 3 angles. We found all 3 sides using the law of sines. And we had to do 2 iterations of the law of sines. All right. What's next? All right, next up, example number 2. Solve triangle ABC if A is 63 degrees, B is 49 degrees, and C is 78 centimeters. All right, I've gone ahead and, for time's sake, drawn the triangle and our table and got it started. So let's just dig right into what we can solve for. First thing, we want to look at our angles and sides relationship. Okay, again, we've got 2 angles, but this time we're given the side in between, or included between those 2 angles. So this time we've got angle, side, angle. Okay, that's okay. Angle, side, angle also works with law of sines. So even though initially we're not given an angle and its opposite side, since we know that the 3 angles in a triangle add up to 180, then we can solve for C and then use that pair there. Okay, so we can do 180. Take away 49, take away 63. And that tells us that our angle C is 68 degrees. So we can fill that into our table. Okay, we've got all 3 of our angles. Now we've got that pair. So we can start our law of sines with the sine of 68 degrees over its opposite side, 78 centimeters. Okay, and we get to choose what we want to solve for first. We're looking for a little a and a little b, so I'm going to start with a. So we know big A. We're looking for little a. Alright, cross multiply, solve for a. We get 78 sine of 63 degrees over sine of 68 degrees. And we should get 74.96. We'll just go out 2 decimal places there. Okay, so that's our side length for A. 74.96 hundredths. That's in centimeters. Okay, so now we just need to find side B. Alright, so again, I'm going to start with the sine of 68 over 78. Okay, if you include your units, that kind of reminds you of making sure that the angles go with the sine and the sides go underneath. It's easy to get those mixed up. Alright, if we're looking for side B, before we make sure that you label your triangle. Okay, we're looking for side B, so we want to do sine of 49 over little b. Solving for little b, doing our algebra, we get 78 sine of 49 degrees over sine of 68. Okay, put that in your calculator. And we should get about 63 and 49 hundredths. That's in centimeters. Okay, so we've got our triangle solved, we've got our table filled out, and we're done with example number 2. Okay, so now let's get into some, we're going to do 3 examples of this type here. Starting off, example number 3, solve triangle ABC if angle A is 30 degrees, little a is 30, and little b is 40. Again, maybe let's give that some units. Let's do kilometers. Okay, so we're looking for angle B, angle C, and side C. Okay, so let's look at our relationships. We've got 2 sides and an angle this time, and our angle is not included between our 2 sides. So we've got side, side, angle. Okay, I'm going to maybe double highlight that one because this is our special case. So remember, in geometry, SSA was not a valid shortcut for proving 2 triangles were congruent. Okay, if you keep that in the back of your mind, whenever we have SSA when we're solving a triangle, then we can use law of sines, but there's going to be some special cases here. So let's work through this one and see what happens. Okay, so we've got a pair of opposites. So we've got sine of 30 degrees is to 30 as, since we're given side B, now we're looking for angle B. So we can set it up this way. Solving for sine of B, we multiply both sides by 40. And we get 40 sine of 30 degrees over 30 in kilometers. Careful. Okay, so let's see. We can simplify this. Divide both those by 10. So we've really got 4 sine of 30 degrees over 3. All right, now we want to solve for B. B is an angle. It's embedded in this sine function. So this is the same as saying the inverse sine of 4 sine of 30 degrees over 3 is our angle B. Okay, so converting from our sine function to our inverse sine function, since we're looking for that angle. Okay, and we can put that into our calculator. So inverse sine, second sine, 4 sine of 30 over 3. Okay, and we get the angle 41.810. So B is approximately 41.810 degrees. Okay, so we put that on our triangle, we put that in our table. Now, here's where the special case comes in. When we do our first round of law of sines with an SSA triangle, there's a possibility that we're going to have not just one solution, but either 2 solutions or no solutions at all. Okay? Now, because this worked out well, we know we're going to have at least one solution. To test to see whether we're going to have a second possible solution, we're going to take that angle measurement and we're going to subtract it from 180. Okay, so 180, take away that angle, and we get, so 180 take away 41.81 gives us 138. 190. Because when we do inverse sine, the range for inverse sine is restricted to just 0 to pi over 2 and 0 to negative pi over 2, then it's only going to give us this answer out, but that's not the only angle that has a sine of 30 degrees. Okay? We know from our unit circle that 30 degrees right here, the sine of that angle has the same sign as this angle here. Okay, this angle is never going to be output from our calculator since it's not in the range of inverse sine that's set. So we need to make sure that we consider the fact that this angle could be in a triangle since it's less than 180. Okay, so if we subtract this angle from 180, that'll give us this other possible angle. And then if we take that and include that with our originally given angle from our problem, so if we add those two together, so 138 plus 30, if that sum is less than 180, then there is another possible solution to this problem. Okay, if it's greater than 180, then there's not. There will just be one other solution. All right, so we're going to have a second possible solution. So what we're going to want to do is build another table. To house our other solution. Okay, our givens are going to be the same. So we've got 30 degrees, we've got 30 kilometers, 40 kilometers, and we're looking for those. Okay, so this time our angle B is going to be that other possibility. Okay, so it's going to be 138.190 degrees. Okay, now we still need to find C's in our other triangle. So I'm going to go ahead and finish this one up first, and then we'll move on to this one. So these are our two possible solution sets. All right, I'm going to get rid of some of this for space's sake. All right, so back to this triangle. So now that we've got these two angles, we can add those up, subtract from 180 to get our third triangle. Okay, if we do that, we should get, this guy is 108.190 degrees. Okay, and then setting up law of sines to find this last side here. Start off with the same ratio that we're given. And then we've got the sine of 108.190 over side little c. Okay, so we want to do sine again to find this side c. Okay, so doing the algebra, putting that in our calculator, we should get 57 2/1000. Okay, so that wraps up the first solution. Now the second solution, we need to do the same thing, but we need to plug in our different C value, because we're going to have a new C value now that our B is different. Okay, so if our B value is 138, and if I had space, then I would draw a totally separate triangle down here and do this whole thing again for this solution. Since I don't have space and time's running out, I'm just going to erase and adjust this one. But I would recommend on paper that you do a totally separate second triangle for this solution. Okay, so we know this angle, we know that side, so if we set up our equation differently, since our C value is going to be different, our C value is going to be 11.81 degrees. Okay, if we add these two, subtract it from 180. Make sure we put that in our table. Okay, so now we're going to do the sine of 11.81 degrees. All right, solving for C, putting that in our calculator, we get 12.28. That's in kilometers. And that wraps up our second solution. So, once again, side-side angle, we've got two possible solutions. Okay, and we've got them both in tables here. Long one. Okay, so got two more examples. We're going to go through these real quick. We're running short on time. Okay, example number 4. Here's our given information. I went ahead and did the triangle in the table starting off for time's sake. Again, two sides and an angle. So we need to flip a switch in our mind and look out for either 2, 1, or 0 solutions. Okay, our first pair of opposite sides, or side and an angle, we've got sine of 82 degrees over 17. And we want to set that equal to sine of c over 15. Okay, and solving for our angle c, so we've got sine of big C equals 15 sine of 82 over 17. Okay, so that tells us that the inverse sine of 15 sine of 82 over 17 is going to give us C. Okay, putting that in our calculator, C is approximately 60.899 degrees. All right, so there's our angle C. Now, again, we want to subtract that from 180 and see if this angle plus this angle is still legitimate. Okay, so if we do so, 180 minus 60 and change, then we're going to get 119.101. And what happens if we add these two together? So 119 plus 82, I don't know what that is, but I know it's going to be more than 180, and that's impossible in a triangle. So this is a good example of one possible solution for a side-side angle. Okay, we went through our first iteration of law of sines. We found our second angle, angle C in this case. We subtracted it from 180 and added that possible angle to our already given angle. It's more than 180, whatever that is. So there cannot be a second possible solution. So we want to go ahead and solve for the rest of these. Okay, so solving for angle A, we add these two, subtract it from 180. Then we get 37.101 degrees. Okay, we set up our law of sines again. The sine of 82 over 17. Now we're solving for little a. So we're going to do sine of big A. Solving for A, skipping ahead a bit, we get 10.355. Okay, that's in miles. And we're done. So one possible solution for SSA. All right, last example. Example 5, solve triangle ABC. A is 36 degrees, little a is 2 centimeters, little b is 7 centimeters. Okay, again, we've got two sides and an angle with the angle not included. So this is a third example of side-side angle. Okay, so let's do the same thing. Let's start with our law of sines. Sine of 36 over 2. And since we have side B, we're going to start off by trying to find angle B. Okay, so sine of B is 7 sine of 36, cross multiplying, over 2. Okay, so if we put that in our calculator and we do, if we actually put the inverse sign in our calculator, Okay, let's do that. Okay, so inverse sine of 7 sine 36 over 2. Uh-oh, here's what I get. Domain error. Okay, what's wrong with that? Did we punch something in correctly? Okay, if I go back to it, no, it looks like I punched everything in right. Okay, make sure I'm in degrees. I'm in degrees, so what could be wrong? Well, if we go and we find out what this is equal to, okay, if we just put that part into our calculator, we're going to find that this part is about 2 and some change. Okay, that's not okay. We're looking for the angle whose sine is 2 point something. Remember, sines and cosines have a range of -1 to +1. We can't find an angle whose sine is outside of that range. So, that angle does not exist, and there's no solution to this problem. Okay, so this is an example of 0 solutions. All right, we cannot solve this problem. Okay, in class tomorrow, we're going to do some applications of this. We're going to practice these on paper in groups and up on the board.